Hi guys, this is O-Level Chemistry, paper 11, November 2021, question 11. The relative atomic mass of chlorine is 35.5. What is the mass of 2 moles of chlorine? So we are talking about chlorine gas. Chlorine gas has a formula of Cl2 because it is a diatomic molecule. So if we have Cl2, that means 1 mole of this gas will have a mass of 35.5 into 2, which gives us a value of 71. And therefore, 2 moles of chlorine gas will have a mass of 71 into 2 because the mass of 1 mole is 71. So the number of moles is doubled, so the mass will also be doubled. So this will result in a value of 142 grams. This makes option D the correct option for this question. Question 12. Methane burns in oxygen and the equation is given. 10 cm cube of methane is reacted with 25 cm cube of oxygen. Okay. What is the total volume of gas that would be measured after the reaction? Okay, so we have 10 cm cube of methane reacting with 25 cm cube of oxygen. However, the ratio of methane to oxygen is 1 is to 2, which means if we have 10 cm cube of methane, it would react with 10 times 2 is 20, 20 cm cube of oxygen, which means 5 cm cube of oxygen is left behind. So 5 cm cube of oxygen would be present after the reaction has been completed. And now, according to the molar ratio, 1 is to 1. So the volume of CO2 produced would be in the ratio 1 is to 1 with methane, and the volume of methane is 10. So volume of CO2 produced would be 10 cm cube produced. So in total, we would have 5 cm cube of oxygen remaining and 10 cm cube of CO2 forming. So 10 plus 5 would give us 15 cm cube of gas after the reaction has been completed. So this makes option B the correct option for this question. Question 13. An aqueous solution is made by dissolving 3.4 grams of sodium hydroxide to make 500 cm cube of the solution. What is the concentration in mole per dm cube of this sodium hydroxide solution? Okay, so the mass given to us is 3.4 grams. The MR of sodium hydroxide would be 23 plus 16 plus 1, which is 40. So the first thing we need to do is we need to calculate moles of NaOH, which would be 3.4 grams divided by 40. This would give us a value of 0.085 moles. Now the question states that this many moles make 500 cm cube of the solution. So 0.085 moles are present in 500 centimeter cube. And they've asked us the concentration in mole per dm cube. 1 dm cube is equal to 1000 cm cube. So 1000 cm cube. The number of moles present in 1000 cm cube can be calculated by dividing 1000 by 500 and multiplying this ratio with 0.085. This gives us a numerical value of 0.17 mole per dm cube as the concentration of sodium hydroxide. So this makes option C the correct option for this question. Question 14. Which statement about electrolysis reactions is correct? Bromine is formed at the anode when molten lead bromide is electrolyzed. Since it is molten, then bromine would be present at the anode because bromide ions are Br negative and they lose electrons to form bromine. So this is oxidation and oxidation takes place at the anode. So this is correct. Positive ions are discharged at the positive electrode. Uh, Positive ions are no positive ions are not discharged at the positive electrode. Positive ions are positive electrode, which is the anode. No, 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 no. Gases are discharged at the anode. Gases are discharged. So this statement is wrong. Sodium is formed at the cathode when aqueous sodium chloride is electrolyzed. No, sodium is never discharged. Hydrogen is discharged. Hydrogen gas. Sulfur dioxide is formed as a gas when dilute sulfuric acid is electrolyzed. No, when dilute sulfuric acid is electrolyzed, the cathode would have production of hydrogen gas and the anode would have production of oxygen gas. SO2 would not be produced at either electrodes. So this makes option A the correct option for this question. Question 15. The apparatus shown is set up to plate a steel key with copper. The key does not get coated with copper. Okay, so the key is attached at the anode. So anode is where oxidation occurs. So the key would undergo oxidation. If we had to coat the key with copper, it should have been placed at the cathode, because if you place copper rod at the anode, it will undergo oxidation. Copper ions will go into solution, and at the cathode where the key would have been present, again the negative terminal, then the copper ions would have reduced and deposited on the key. So basically, the position of the two electrodes are incorrect. So let's see. Which change needs to be made to plate the key? Increase the concentration of aqueous copper sulfate? No, the copper sulfate is not being used in the proper way. We do not need to change its concentration. Increasing the voltage? Same thing. We do not need to change the voltage. Right now, the positions of the electrodes are incorrect. Replace the solution with dilute sulfuric acid, then copper will not be deposited in that case. Reverse the electrical connection. Yes, yes. Switch the positive and the negative terminal. This would result in the steel key being coated with copper. So this makes option D the correct option for this question. Question 16. Which process is endothermic? Atoms bonding to form molecules. So basically bond formation. So bond formation is exothermic. It gives off energy. B, the chemical reaction occurring in a fuel cell. When a fuel cell is working and the chemical reaction is taking place, it gets heated up, which means energy is being released. C, the reaction of carbon dioxide and water to produce glucose and oxygen. CO2 plus H2O to produce glucose and oxygen. This reaction is exothermic. No, 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 no. The backward reaction is exothermic. This is a reversible reaction. So we have CO2 plus H2O giving us C6H12O6, which is glucose, plus oxygen. So now in this case, we know that this reaction going from glucose and oxygen to CO2 and H2O is exothermic. This is respiration. This is the glucose being used up in the cell. So the production of glucose, which is photosynthesis, would be endothermic. So we need to find a process which is endothermic. So option C has an endothermic process stated. D, the reaction of methane with oxygen to produce water and carbon dioxide. This is called combustion. Combustion is always exothermic. So based on our findings, option C is the correct option for this question. Question 17. The reaction of hydrogen with chlorine to form gaseous hydrogen chloride is exothermic. Okay. Hydrogen plus chlorine to form HCl is exothermic. The total energy of bond formation is greater than the total energy of bond breaking. So the bonds of the reactants are broken and bonds of the products are formed. So bond breaking requires energy. So energy is required to break the bonds of the reactants, and energy is released when bonds are formed of the product. So energy release is exothermic. So if the overall reaction is exothermic, greater amounts of energy is released compared to the amount of energy required. And this statement says the total energy of bond formation, that means the product, the energy released is greater than the total energy of bond breaking, which is the energy required. So the energy release is greater than the energy required. This option is correct. Next, the total energy of bond breaking is greater than the total energy of bond formation. This statement is the exact opposite of the first statement. This would make the reaction endothermic, not exothermic. So this is wrong. Next, the temperature of the reaction mixture falls during the reaction. If the temperature of the reaction falls, it means that an endothermic reaction is taking place. So this is also wrong. Next, the temperature of the reaction mixture remains unchanged during the reaction. No, the temperature of the reaction mixture would increase during the reaction because energy is being released. So this makes option A the correct option for this question. Question 18. The equation shows the reaction for the manufacture of ammonia. Which change will decrease the activation energy of the reaction? The only thing that affects the activation energy is the presence of a catalyst. Nothing else will affect the activation energy value. So, option A, addition of a catalyst. Yes. Option B, decreasing the temperature. This will shift the equilibrium left or right, but this will have no effect on activation energy. Increasing the concentration, again, if the concentration of reactants is increased, equilibrium shifts towards the right. If the concentration of products is increased, equilibrium shifts towards the left, but nothing happens to the activation energy. And increasing the pressure favors the side of equilibrium with the lesser number of moles. So in the given reaction, the forward reaction would be favored and the equilibrium will shift towards the right, but the value of activation energy will not be affected by increase in pressure. So this makes option A the correct option for this question. Question 19. Which statement about oxidation and reduction are correct? Reduction can involve loss of oxygen. Okay, so reduction is gain of hydrogen, loss of oxygen, and gain of electron. So statement 1 is correct. 2. Oxidation can involve loss of hydrogen. Yes, oxidation involves loss of hydrogen, gain of oxygen, and loss of electron. So statement 2 is also correct. Statement 3. Reduction can involve loss of electrons. No, loss of electrons takes place in oxidation. So statement 3 becomes incorrect, making statements 1 and 2 correct, which results in option A becoming the correct option for this question. Question 20. Aqueous ammonium nitrate NH4NO2 decomposes when heated and the equation is given. In this salt, the N ion is, this is the N ion, NO2 minus. The nitrogen atoms in the dash ion are oxidized during the reaction. So we have NH4 positive ion containing nitrogen and we have got NO2 minus ions containing nitrogen. NH4 are converted into N2 as well as NO2 being converted into N2. Now, N2 has an oxidation state of 0. So we need to find the oxidation state of nitrogen in the ions present. So in the case of ammonium ion, hydrogen will carry a positive charge. So hydrogen having a positive charge will result in nitrogen carrying a negative charge. So let's call that x. X plus 4 is equal to plus 1 because the overall charge is plus 1. So x would be equal to plus 1 minus 4, which gives us a charge of minus 3. So this should be correct because we had already predicted that the charge on nitrogen should be minus. So it's minus 3. Now going from minus 3 to 0 is loss of electrons. This is oxidation. Let's look at NO2 minus now. In NO2 minus, nitrogen will have a charge of X and oxide ions will have a charge of -2. So the equation becomes X minus 2 to the 4 equals -1, which is the overall charge. X would be equal to -1 plus 4. X is equal to plus 3. So X being plus 3 is going to 0. Plus 3 to 0 is gain of electrons, and gain of electrons is reduction. So the nitrogen atom in ammonium ion is oxidized, and the nitrogen atom in NO2 minus ion is reduced. This statement says the nitrogen atom in dash ion are oxidized. So this is ammonium ion. So the first one is supposed to be nitrite ions. So C and D. And out of these, the second one is supposed to be the ammonium ion, which is in C. So this makes option C the correct option for this question.